And this is what ThoughtWorks believes, and it is fully sponsored and organized by ThoughtWorks. So let's get started. Before we start, I let me quickly go through the agenda today. So we have today two interesting topics, which is event-driven architecture by Kevin and Janki. And after the session, we will take a short break of 5 minutes, followed by another interesting topic, which is software architecture decay by Sunil Yadav. And yeah, before we start, let's talk about the ground rules so that we can make our Geek Night more communicative and effective. The first one is raise hand. So in case if you have any doubts or queries, if you want to talk to our speakers, please feel free to raise your hands. There is a option in Zoom in the right bottom, so you can choose that raise hand so that we can enable you to talk with our speakers. And the next one is Q&A session, which is if you have any queries or anything which you want to ask or share, please feel free to post it in Q&A session so that our speakers will pick it up and will try to answer. And we have last thing, survey, which most of us know that ThoughtWorks gives so much importance to feedback. So after the session, there will be a survey form will be sent to you. So please feel free to drop out your survey, your feedback about how was the event and about how it was organized. And if you have any feedback about our speakers also, please feel free to pitch it. Yeah, so that's about it. So let's start with our first session, which is event-driven architecture by Kevin and Janki. Yeah, welcome you both. Over to you. Let me stop sharing.
Thanks, Kirti, for that. Let me share my screen. Hope my screen is visible.
Yes, Kevin, go ahead.
Cool. So welcome to this talk. So this talk is mainly about event-driven architecture and how we can make the best out of it. So in this talk, we are trying to cover more about architectures, how event-driven architecture got evolved, and the patterns that were involved in event-driven, and also about how we can send events. Also in detail, I talk about event sourcing, one of the pattern that is used in the event-driven architecture. So before getting into event-driven architecture, let's just have a quick understanding on architecture evolution. So we have seen this monolith a lot, right? We know how monolith works and the problems associated with this. So this you can consider as a food delivery application, which is right now on a monolith architecture. And there are many domain models like order, kitchen, and delivery. But one thing is like monoliths are not bad. Like they are very good solution if the project is small and if it is not that complex and things like that, we can still go with the monolith. The problems start to evolve when the project grows, the team size grows, then we will have a problem. So the main problem is like now we can see there are different domain models here. There won't be any boundaries. Like these boundaries slowly start to fade away, and order start to do some part of kitchen, kitchen start to do some part of order, and things start getting messy. So that's one of the problem with monoliths, and also it will be very difficult to deploy and maintain and all. So to avoid that thing, one way of doing it is to define the boundaries. So you can see now we have splitted this monolith into a microservice. There are different way of doing it. One way is using business solution, or like other ways to go with a subdomain. So here in this example, we have broken that using subdomain way. You can consider like the domain models which we had in the monoliths are transferred into individual services. So you can see there will be a fixed team to work on this thing, and also a boundary is defined. So this service is a small and independent service which take care of only the order. It won't have any understanding about kitchen and delivery and things like that. So this is how we have decomposed this thing in a nutshell. So And the other part, like it's not that simple. If we are not decomposing this application in a proper way, we will end up in some other problems as well. So there should be a guidelines in which we should decompose it. Like when it comes to programming or software development, we know about solid principles and things like that. So some of those we can use here also. So you might have heard about single responsibility principle. That's one of the first principle in solid. So which says like a class should do only one and only single responsibility, should not do some other responsibility. So the same applies for the microservice. Like here you can see the order service takes care about order only. It won't do any work that associated with the kitchen and things like that. And another property is like a common closure principle. So this is an extended principle defined in the solid principle along with the solid principle. So this says like if you have any common feature or common classes that are getting changed frequently, that need to be kept under a same package. Same way, when it comes to microservice, we should really develop a microservice. We should not end up in creating a distributed monolith. Like distributed monoliths are services where if you deploy a service, another service also need to be deployed together because there is a tight dependency between them. Let's say, for example, if order is deployed because of some reason, if you want to deploy kitchen also, it's a anti-pattern and it's an example of a distributed monolith. So if you feel like there are some things that are getting changed together, yeah, we have to rethink and we have to bring them back into a single service. So that dependency will also go away. Yeah, so that's what this distributed monolith try to avoid this thing. And anti-dot for that thing is a common closure principle that we should apply on that. So now we have successfully divided this into different services. So now let's comes the challenge. It's one of the main challenges in the process communication. When it was a monolith service, the domain models or the objects can talk together because they were all in the same memory space. But now we have splitted them apart, so we cannot do that. So ideally, we have to go with ways of communication. So two types are there, like synchronous way and asynchronous way. Let's see the synchronous way. Like you can see the order service talks to kitchen and things like that. So this is basically a request response communication model, which mostly happen over a HTTP protocol. Like the sender will wait for a response from the to whom they are sending. So one of the issue with this service, this synchronous way of communication is it makes things a little coupled. So when it comes to software development also, we try to avoid this coupling, right? So that will have a lot of advantage in the software development part. Same will be therefore when it comes to microservice as well. So the microservice should be something that should be deployed independently and that should have to do their own task and all, right? So to avoid that thing, what we can do, like when we are discussing from a software development perspective, one of the way in which we avoid coupling is by inverting the dependencies. Like we try to avoid this direct dependency between two services. So if we want to go in that direction, one way of doing that is to put a queue in between. So you can see the service order now is talking to a queue. There is no direct connection with the kitchen. So basically we are avoiding a runtime dependency here. So they won't wait for any response. This is not a request response pattern anymore. Like order will send an event and the event will go to the kitchen. So order is not worried whether it has reached or whether kitchen has processed and things like that. And also we can see like if any of the services goes down, the availability of order service is not hampered because order will just send message to the queue and it won't wait for any response from delivery module, let's say. But when it comes to synchronous communication, if the delivery was down and if order is trying to send some request to delivery and if it is not able to fetch, there is a coupling here. So the order will also go down. So the fault drop can be reduced at a much to a greater level in asynchronous way. So this is typically based on a event. It's about event sending events from one service to another. So this is how the event-driven architecture comes into picture. So you can see like the service produces, detects and consume event, and they react based on the events. So that's the whole part about event-driven architecture. So now let's see why we are thinking about event-driven architecture. It's independently deployable services. One service can send events to multiple consumers. It's easy to plug and play, because let's say if you want to introduce another service, let's say one SMS module, which will send an SMS or a notification whenever the order is created or delivered or things like that. We can introduce a new service here, and we just need to connect it with the queue. We don't have to tell or make any change in the order service. And also helps in downtime. Like in case of the delivery or any of this application is going down, the order will send message to the queue, and it will lie there for some time. So maybe there is some time it will lie in the queue, and maybe it will go to that letter queue, and all that will happen. But still, once the kitchen comes back, it can still poll all the events which were not read in the queue, and this can start processing those events. And also there is not a civil line thing, so there is still a lot of trade-off that we need to see. A few things are like variable latency. One thing is variable latency, and because of the network in place, uh, obviously there will be a latency in sending events and all, which may not be the scenario when it was a monolith, because everything was in the same space. Same way, because of the high availability, because one of the main advantage of event driven architecture, we can distribute, we can replicate them in multiple location or multiple uh, servers and things like that. Because of the high availability, yeah, anyway we will go into eventual consistency, because the state of particular data may not be updated equally in all the environments, and sorry, all the replicas. It may take some time. Another thing is like return values. There is no return value. Like event will, it's like we are sending an event, we don't know whether it got processed and things like that. That's another part. And also it is little difficult to debug, because we are all dealing with events, right? It's happening in an asynchronous way. It's not a direct request response thing. So there are either we should have a robust logging system and other automated log analysis to parse and try to help us on that. So these were the some of the advantages and disadvantages of event-driven architecture. So now let's take a step back, and we want to see how we can develop a business logic around a microservice, right? So when we were discussing about the monolith, we said there was a domain model. Then when it came to microservice, so we created a service based on a domain model. Now we'll take a little more close into the same thing. Like you can see, we have a domain model, and we are trying to see what exactly happens inside that. So in a traditional domain model, the boundaries are still fixed, like it's not a fixed boundaries, so it varies. So that's a problem. So what we are doing here is like we are trying to bring the DDD aggregate pattern to enforce the boundary in a better way. So what happens here is like you can see this like still like a domain model, but there will be a root aggregate which will have some cluster of other classes. So if you find it, I know this is a different topic we are discussing, but if you're finding it a little hard to grab this aggregate pattern, you can treat it like a class which will have some of the objects within it. And some rules of these aggregates are like there will be a root, and through the root only you can talk to the other objects. So you cannot directly talk to a delivery info or a payment info or order line. So everything should happen through the root only. And another point is like the aggregates don't have a object reference. Like let's say if you have one more aggregate, let's say for kitchen, there is no direct object reference between them. You can connect them only through a primary key. So you can see there is a restaurant ID here, consumer ID here, and things like that. So basically these IDs are the aggregate ID of a restaurant or a customer aggregate. The main idea behind this is like even if the aggregate lies within a same service, or if it is lying in a different service, there won't be any problem, right? Because we are still dealing it with the IDs. So as you can see, as I said, it's a cluster of domain objects that can be treated as a single unit. This will ensure a local transaction. Like if any change happens to any of these objects, this will ensure it will happen there will be a atomicity here. And also whenever a change happens to the aggregate, what happens is like aggregate will throw a publish an event. So that's how the one of the key factor here when it comes to event driven architecture. So you will have an aggregate will process the request, and or it will, if it is you can call it like it will, you will process some of the let's say you process the order or you make the payment and things like that. So once that is done, so here a state change will happen. So once the state change will happen, and for that state change we will publish an event. So that is what we call domain event. So we have covered quite some part of the event driven here. So like we like to take some QAs here. If you like, we can have a we can collect some questions, and we can, if you have any clarity required, we can discuss before progressing further.
Kevin, I think there is a raise hand. Let me. Yeah, let me unmute.
Hey Kevin. Hi,
Hi.
Yashwant here.
Hi.
So Kevin, can you take up some real world application, let's say like LinkedIn or Swiggy, and can you explain a module how the event driven architecture works there?
Yeah. So I think we'll go back and we'll take an example of Swiggy itself.
Sure.
So like when we see Swiggy, like whenever an order is coming, like this order will get created here, and I will take this as an example where then aggregate also will come into picture. So whenever a request is coming there, we will create an order aggregate, right? So the order aggregate is created, and that order aggregate will trigger an event saying like order created, and that will go into the queue. So the queue, what it will happen is like we are sending some message to the kitchen saying like, hey, this particular order has been created. You need to prepare some food or something. Sorry, we have to prepare some whatever item the customer has requested. So that will go into the kitchen. So once the kitchen is processing, once they are done with the, let's say if they are making some progress in their side, that part also some events will get triggered, and that will be pushed back to the order. So now order is saying like, okay, your food is prepared. In Swiggy also we can see different stages in the order, right? Like your food is in prepared. So let's say you have an event like food is prepared now. So now the order will process that thing, and order aggregate will make another trigger that will send another event to the delivery guy. Like order is the food is prepared now. You should think about the delivery. So now an event will go to the delivery system, and the delivery system will process it, and they will send like, okay, your delivery person has been assigned. So that event will come back, and you can see in the order service what is the status of the order. So basically, we are actually connecting all these nodes using queues, and these queues, we are communicating using these events. So the other part we discussed was about the aggregate. So aggregates are again to make a local transaction here. So what happens is like we will have different objects within an order. This is not one object cannot do an order, right? So there might be different parts to it. So the aggregate is something like you can consider it as a cluster of different domain models. So based on different scenarios, maybe let's say if the order has came, the order line item might change. The delivery has happening, so delivery information might change. So for each of these things, there will be a state change on this aggregate, and that will emit a domain event. So this is what at a high level what's happening.
Yeah. Thank you, Kevin. Yeah. So here the payment info and delivery info is these are the different objects inside the order aggregate, right?
Yes.
They don't have any say like there won't be a another microservice called as a payment or something like that?
There might be that, but these are like some objects associated with the order, like just to know what is the status of payment or what happened to the delivery, like that.
Sure. Yeah, makes sense. Thank you.
And also when you see these objects, so for these subdomain objects, there is a direct object reference is there. But let's say an order aggregate and there might be a different kitchen aggregate. So for them, we don't have any direct object reference. Object reference means, like I'm saying from programming perspective, like a variable connecting the objects. So you have that here, but when it comes to another different aggregate, you don't have such a connection. We are actually trying to avoid, we are trying to make the boundary more stronger. Like, so now this aggregate object will deal only with, let's say for this example, these many classes or objects. And
Okay.
for each order, there will be a different aggregate objects getting created. For your order, there will be one order. Ideally, there will be one order object get created. Let's say if I am placing an order, for me, a different order object get created, and it will emit its respective events.
Okay. Yeah. Thanks, Kevin.
Yeah, thanks.
Thanks, Rajkumar. Kevin, we have 3 more questions in the Q&A session. So
Yeah.
first one is from Said Hussein. I hope I am pronouncing it in a correct way. What would be the event naming convention if every state change on aggregate route is getting published as domain event?
Yeah, the naming convention is should be a past tense, like or created or received. That's the pattern that we used to use, like if order created, because it's something that happened, right? So usually we go with the past tense. It should not be a continuous tense or like something or a future tense, because it should be, it's something that happened. That's why we are having event. So always try to use a past tense. So there's another question also, the concept of aggregate is not very clear. So as I said, like if it's, I know it's a little advanced topic to discuss, but you can think it like an order object, which has a defined boundary. And whenever a state change happens to that order object, it will emit an event. Maybe let's picturize in that way. And yeah, that's all I can say right now. Another question is like whether the synchronized APIs in event-driven architecture is an it's not an anti-pattern, like saying, but sometimes it will work. It depends on the situation. Like it's not like event-driven is the best thing. Like sometimes when you want to have a very consistent system, then you should have a synchronous communication there. So it depends on what kind of problem you are trying to solve. If you're okay with eventual consistency, you can go with event-driven architecture. But if you're not okay with eventual consistency, like you should ensure things happens in real time, then you should go with synchronous communication. It's also same like monolith. Monoliths are also not bad. Even when I started thinking, I thought monoliths are bad. We should think about microservice only, because that's not the thing. Like even monoliths will work in many scenarios and we can still use it. Same way, synchronous APIs also will work. It's not an anti-pattern. What kind of queues can be used in kind of architecture? You can use any queues. Like it's no, we are not specific based on the infra you are using. If you're using AWS, you can use SQS, SNS, things like that. Or if you're using like Java wise, maybe Kafka should do. So there is nothing very specific. Queue can be anything. Any queue you can use.
Thanks, Kevin, for taking all the questions. I think we have one more attendees who raised their hands, so I will allow him to talk. Yeah, I think Mativana Mani, are you able to talk?
Hello.
Yeah, go ahead.
Kevin, I have one doubt. So,
Yeah.
we are saying this is a event-driven architecture. Here, while customer placing the order, first they have to complete the payment, right?
Yeah.
Payment confirmation, we have to wait for the payment confirmation. So in that case, that will be a synchronous communication, right?
It need not to be a synchronous communication. Like why I'm saying that is because when you are placing an order, it depends on the way we are dealing with this particular problem. So we can send an event to the payment gateway system, and they can process, and they might take some time to reply back. So by that time, we might have seen some messages like your order is in progress, or let's say typically I've seen in Amazon, like when we are trying to place and try to buy something, we have seen something like the payment gateway has not yet replied. We will make your order in, will ensure your order will be placed once you get a confirmation from the payment gateway and things like that. So it need not be a synchronous, but again, the question is like how you want it to be. Like if you want to make it very real time, you have to use a synchronous communication. But if you're okay with such a delay, yeah, then we can go with event-driven architecture. That's my thought on that. Yeah.
Is it possible to combine both? For example, once I get the payment confirmation, then only I will publish the events for delivery and kitchen events. Is it possible? Combining both the models, synchronous and asynchronous.
Hybrid way of hybrid part is also there. Like you can combine the both synchronous and asynchronous one. That is also possible. But it all depends on the problem that we are trying to solve. So if we want to ensure like the payment happens, then only we should send an event. Yeah, obviously it has to be in a synchronous way. And also one part which we are not covering here is the consistency across the services. Like as you said, if the payment is failing, the order part need to be reverted. We are actually not covering that in this discussion because that's another wide topic. So Saga patterns are used for making a consistency across the services. So we are not taking that in this particular session. So that's how a consistency is maintained across the services in a microservice architecture.
So this aggregator pattern is different from Saga pattern, is it? Because I thought whatever aggregator you are saying, that is equivalent to Saga. How is it different?
Aggregate is different. It is not having direct connection with Saga. Aggregate is something, this ensure a local transaction. Like in the sense, if you make a change in the order line, this particular part, I mean, this is not like, how can I say, this is like a transaction, you can say. Like if you make a change in the order line, this will happen. Or if you make a change in info, this is like a single transaction, this will happen. So the point of having an aggregate itself is to make this local transaction. And there are rules like we should only talk to the aggregate through the route. So the events and all can be created. You cannot directly connect with an order line or a delivery info from outside. It should always happen through the route aggregator.
Okay, thanks.
Yeah, welcome.
Thank you. There is one more question in the chat. Because of the time concern, we will try to answer it in chat. I think we can go ahead, Kevin.
Okay, thank you. Yeah.
Okay. So we already, sorry for that. Okay, we already spoke about what aggregates are and how event-driven architecture works, right? Now let's see how the event flow happens in the system, right? There are some 3 different categories in which you can divide this event communication that happens in the entire application. Where you have multiple services, these services will have aggregates. So the first one is event notification. Event notification is when a particular state change happens in the aggregate and event is emitted. This event will only be like, it will not have any extra information. It will just say that some state change has happened. What has happened, where and what exactly is the, like I'll talk about it in example in the next slide, but basically this will contain minimum information about some state change has happened. Then there is event carried state transfer. So event carried state transfer is when, along with saying that, hey, there is a state change, you send out some required information such that the consumer of this event need not do another query to fetch what was the change. For example, talking in the food delivery application terms, say if order is placed and an event is emitted saying order is placed, but you do not have information about what are the details of food items or any items that are ordered with the this particular order. So in that case, it will be even notification. And if you are sending out some details where the kitchen consumer service need not go and query that, hey, what was the order placed, it might be an example of carried state transfer, right? Then third one is event sourcing. Event sourcing is when a series of events are replayed or folded to get the current state of your aggregate. That is event sourcing. We will actually get into the detail of event sourcing. So hold on to this one. But the main difference between first two and third is, in first two, we just store the final state of your aggregate. We do not have like what all events led to this current state of aggregate. Whereas in event sourcing, we are storing the series of events that have occurred in the application. We are not storing the current state of the aggregate. We are actually replaying the events to get the current state of aggregate, right? Now let's see the example for first two. So this is a setup on AWS, and I'll quickly run all of us through this. PIM is actually, this is e-commerce website or application setup. And PIM is the product information management system, which holds all the information about various products that are available on the application, right? Now, any change in the product, for example, there is some product which the variant images have changed, or price has changed, or the category of that product has changed, or a new sale is added. So maybe the product will move to that sale category. Any such change is actually sent, that will be a state change, right? So that state change will emit an event to SQS. This SQS has a DL queue, which is dead letter queue. Kevin just explained why we use dead letter queues some time back. So this state change will be saying like, hello, say 100 products have been changed, and these are the changes in the product. So queue will store this event. And as soon as there is an event in the queue, a Lambda function is triggered. This is possible to do in AWS, right? So this Lambda function is a consumer of this queue. It will try to fetch the information and process it. What it is doing, will come to that. But basically, just see these three components. This is like order, queue, and kitchen. You have PIM, you have a queue, and you have your some application logic, which is processing that data, right? Now, because along with the event, those 100 variants, 100 products are also sent. This is an example of event state transfer. It is already carrying the information of what state is changed. So that is your second category. Now, what this products Lambda function will do is, it will try to process all those 100 products and store the updated information in database. Along with that, it will create some reports, which it will feed to an S3 bucket. This is search feeds bucket. As soon as there is some object upload in this S3 bucket, another Lambda function will be triggered. Now, this trigger from S3 to Lambda function is just like, hey, I have an object upload. It will not tell the file that was uploaded consists of 100 products, 50 products, what are the products, nothing like that. It will just say, there is an upload in this bucket, you probably need to do something about it. So this Lambda function, search Lambda, will get the objects from S3 and read them and populate the same in constructor.io. What is constructor.io? It is actually a search provider. So this actually, whenever you go, say it is Amazon.com. So whenever you go there and you try to search something in the search box and it gives you results, that is what is handled by constructor.io. For example, any website, this is the search provider. So this is the entire flow, a part of entire flow of the e-commerce application. And we saw two examples here: event notification, event state transfer, right? Now, the third one is remaining, which is event sourcing. Let's get into some detail about it. Basically, like we saw in the aggregate slide, there are series of events that happen. We fold those events and we get the current state of our aggregate, right? So that is event sourcing. One of the examples of event sourcing can be your Git, your version control system. So any state change in the aggregate adds event to the event store. What is an event store? An event store can be your event stream, like data kinesis in AWS, or it can be a combination of any database and storage. Storage is like S3 maybe, which is storing the status of whatever has happened, and a queue service. So you see here, this is a table. It's like a database table which shows what all events have happened in the, again, we are referring to food delivery app. So you see the entries are like event IDs are there. These are unique identifiers, and usually they are given in incremental order. So 102 event would have happened before 105. And then there are event types like order is created, approved, shipped, and then delivered, right? And then which aggregate does this event belong to? It belongs to order aggregate, all of them. What is the unique identifier of that aggregate, order aggregate? It is 101. So this information, if you don't have any idea of what is happening currently in the application, and I ask you that, can you tell me what is happening? So you probably might want to start with the start when the application was launched and run all these events. We call it folding. Fold all these events and then come up to a current state where you can say, maybe, you know what, we processed total these many orders. The orders were related to these items, and these were the dates when they were processed. But you get that current state only by folding these events. Now, you already have producers of events. You have event source where you are storing events. What happens after that? So these events from the event source are published to queues. That is done in two ways. If you see here, publishing events to message broker. So it is done in two ways. One is polling the events table. This is your events table. So there will be specific event publishers which continuously poll the events table to see what are the new records that are added here, and which means new events were created which were added to the store. So they will know that, okay, these needs to be sent forward to the consumers, right? So if we talk about food delivery application, event publishers will continuously fetch these events and send to kitchen. Whenever it's order created, it will send to kitchen and notify that probably you need to start cooking, you need to start preparing something that needs to be delivered. Similarly, one is polling way, the next is transaction log tailing. So in this case, take example of DynamoDB in AWS. So DynamoDB will have a file which will contain all the transaction logs. It will have deletes, updates, and inserts from the database. So event publishers will look out for the inserts, because whenever an event is inserted in the event source or the DynamoDB table, insert statement would have been logged in the transaction log file also. So it will look out for all those statements and try to replay them. So these are the two ways where you actually send the messages to the message broker. In AWS, it will be your SQS queue. Now, how do we recreate? We have been talking about we recreate the state of aggregate from the event store. How exactly does that happen? Let's see that. So at some point you have some event one happening, right? Then there is another event that has happened, which is event two. These are all in your event store. And then there is third event. Similarly, series of event will happen, and you have an example here, say a total of n events have happened. Now I want to recreate the state of order aggregate to understand that today at this point in time, order aggregate has done what work. Okay, so I will start folding events from 1 till n. Now every time, and there will be more events added to this, right? So every time I want to do this, for example, you take example of banking application. I have opened some bank account at the age of 18, and you want to calculate what is the current balance in my account. So there will be events like Janki withdrew 5,000, Janki credited this much, and this much she swiped on in net banking, and all those events will be there. Now you, from the age of 18, which is like 15 years, you will replay all the events and find out what is the current balance in my account, which is impossible. It is very costly for the application to replay all the events or fold all the events always. So to optimize such a process, we actually do snapshotting. So all these events will be added to a snapshot, and the final state will be stored in the snapshot, and this will be a version n. Okay, now say in future new events come, n+1, n+2, and then I want to recreate a state of the current state of that aggregate. What would I do? I would load the snapshot with version n, and I will fold n+1 event on top of it, and then n+2. That will give me current state of my aggregate. right? So we are not going through 15 years. We are just, say, yesterday we created a snapshot. So whatever transactions happened in those 24 hours, we are just calculating those, which is optimized. Now, when do we do such a thing? So there are different options for you. Some people would prefer to create a snapshot after every event. Some people try to create snapshot after, say, every 10 events or 20 events, depending on how your requirement is. So after every number of events, you create a snapshot, or you create snapshot periodically, like weekly you create a snapshot. Or sometimes people create snapshot depending on particular kind of events. Say there are insert events only, then I want to create a snapshot, or there are big withdrawal events, then I want to create a snapshot, something like that. So again, whenever you are designing the application, these are the factors you can consider and choose and make a decision. Okay. So now we know what are domain models. Order, kitchen, delivery are the domain models. We know what are aggregates. Scope of the aggregate is within the order domain models, right? And domain events are something that are emitted by aggregates. So if your same example we take of the bank account, do you think every event will have a schema? It will have some fields and all of that. So do you think the schema will never change in those 15 years? Obviously, there will be some change in the schema. So how do we tackle that? Do we update all the older events with the current schema version? Is that possible? Because there's so many events. And even if we somehow manage to do that, the next requirement is event store needs to be immutable. You cannot keep modifying event store due to some reason that has just randomly occurred. And then if you want to start from scratch and see how things were, because that's the main goal. We are capturing the history of all the aggregates. So we cannot modify history. So these are two opposite things. There is schema change, and there we still need the event store to be immutable. How do we handle that? There is something called upcasting. So what upcasting does is, whatever changes are not backward compatible, say the event schema that was when I was 18 years old and when I opened the bank account, first event that happened in my bank account, the event schema of that and the last transaction I have done are different. So if these are not backward compatible, upcasting will handle these events and do some processing on top of it, such that they can be consumed by the aggregate or by consumers, other services. How, when, where does that happen? So who does this process of upcasting? There's a logic that you develop, which is called upcaster. So upcaster modifies your events from its original version when the event was actually created to whatever the latest schema version is. Okay, I'll move a little fast. We are running out of time. Then when does this happen? So for example, we are reconstructing an aggregate. At that time, we'll fold all the events, right? So during the folding of events, it will upcast the event and then fold it, such that we are not getting into any schema issues at that time. No conflicts. Where does it happen? It does not happen in the database or on the disk, because we need to make sure that the event store is immutable. It happens on the fly in the memory of the upcaster. Whenever upcaster is processing it, it will do it in the memory. Cool. Last slide. Event sourcing advantages and drawbacks. So what are, like Kevin was telling, it's not like all good. You have good and bad parts of it. Depending on what problem you are trying to solve, you pick this or you pick some other solution that is available. So let's talk in detail about why event sourcing, what are the advantages and what are the disadvantages. So reliably publishes, we'll take example of Git here, reliably publishes domain events. Every commit that we do, we know it is stored in the VCS, right? Tomorrow, if we want to go and check on some things, we will get history there. It preserves the history of aggregates. So if we need to audit something, we can go there and we can check that, hey, when did this change? Who made the change? And then provides a developer with a time machine. So say we need to troubleshoot something has gone wrong. So same thing, we can actually go back in time. We can fold events and see that on 100th day of our application, everything was fine. What happened on 101th day? So we can fold that and check, right? Then these are advantages. Coming to disadvantages, it has the complexity of message-based application. So we all know that how do message brokers work? Message brokers work by assuring that at least once the delivery of message will happen, which means message might be delivered multiple times. So whoever is consuming the message needs to be intelligent that it will not act twice on similar events. It needs to get rid of duplicate events. Then evolving events can be tricky. So the solution to this is upcasting, which we already discussed. So I'll not get into the detail of it right now. Deleting data is tricky. So say for example, we want to delete some say I have pushed my Aadhaar card value somewhere in the event, right? I want to delete that. How does delete work in event sourcing? It's actually a soft delete because it needs to preserve the history. So it will soft delete, and whenever next time that aggregate, say I'm deleting an aggregate itself, it will be marked with a delete flag. Next time the consumer calls for that aggregate, it will just throw a deleted event that I am deleted. But actually in the database, all its history is still stored, which is not okay in many cases. Like if it is information like Aadhaar card or PAN card or something like that. Solution for this is encryption, and querying the event store is challenging. So today, if you want to query event store and check how many consumers are there in this bank who are running out of the credit limit, there is no column where we store current credit limit. We always fold events and see what is the balance, right? Or what is the credit. So you will have to do that for all the consumers of the bank and then make a list of whoever is running out of that credit limit. Even that is like very time consuming, right? Cool. Any questions from anyone?
Hi, Janki. Yeah, we have some questions, so we'll just try to answer one only, and you, Kevin and Janki, can reply them in the chat.
In the chat, okay.
So we can take the first one. Does the event source pattern makes the event table a SPOF, since a whole application will depend on the table consistency?
Where is it? Sorry. Does the event source pattern makes the event table SPOF, since the whole application will need table consistency? Kevin, you want to take it? Actually, we'll start replying in the chat. Is that fine?
Yeah, Janki, that should be fine.
Thanks.
Okay. Yeah. Thanks, Kevin and Janki. So because of the time constraint, our speakers will reply in the chat. So before moving into the next session, let's take a quick break. And we are running out of time. So let's take a short break, which is 2 minutes. And we will be back by 2 minutes. Hello, everyone. Welcome back. I know it was a interesting and long session. We were supposed to take 5 minutes break, but because of the time constraint, we are starting again. So, welcome back again. Our next session is about software architecture decay by Sunil Yadav. So, I'm not delaying it much more. Over to you, Sunil. Let me stop sharing.
Yeah, thank you, Kirti. Let me share my screen and just confirm whether my screen is visible or not.
Yeah, Sunil, it's visible.
Okay, so welcome everybody. I'm Sunil, and today I will be talking about this software architecture decay. So after a good session on the event-driven architecture, this is the one we would be ending tomorrow's Geeks Night. So without wasting any time, let's discuss about the agenda of this session. So basically, we'll be covering the significance of this session. Basically, we often find ourselves not much giving much time on the decay part or the some tech dev part. So we will discuss what are significance of this session. Then we'll actually briefly discuss about the software architecture and the decay. Since the software architecture has already been covered in the last session, greatly basically monolith architecture, microservices, and the event-driven architecture. I will not cover much, but a little part of it. And then moving to the next and defining the tech debt. What is tech debt? Code smells and architecture smells. Then we'll come to the erosion, software erosion, and then we'll briefly talk about the smells. What are those smells? How to look forward to those smells, and then the mitigation of those smells in depth using tools and some practices that we often follow in ThoughtWorks. And then we'll have a quick Q&A. So starting with the significance, when you start in the project, we all know what the current trend is. So you are starting with the monolith. You have small client requirements. You have small client base, and suddenly you start getting requests, more and more requests, and you have to migrate your architecture from one architecture to another architecture, and then and more services you are just adding in and evolving your the architecture. And with this evolution, it becomes very hard to incorporate more and more functionality to it. It becomes complex task for you, for as a developer for us. And we also see the current trend is about fast changing tech stacks. So today we have version 2 of something, then tomorrow we have version 3 of that, and it might happen that is not compatible with the last with the other dependent components in your system. And one more thing that we recently found was basically about Log4j. Log4j is a very known and widely used library, and we saw how a single criticality, the vulnerabilities in that Log4j has hampered most of the big projects. These are all current trends, and what these current trend may lead to, that is a point of thought. So tech debt, of course, because you have X number of services and you are not able to cope up with all the changes that is happening in the service. It may lead to tech debt. We will talk about tech debt in detail. We have a dedicated slide for that. And architecture and code brittleness, basically this is the phase where you are not able to incorporate any more changes or any more functionality or feature in your code base. So your code is brittle, basically. You're not able to incorporate any changes in your code base. Security vulnerabilities in the project, that is self-sufficing statement, because today we saw the remote execution vulnerability that was in the Log4j as well as that was in the Spring Boot version 5 point something. So coming to the first topic, that is software architecture and decay. As I told you, I will not be talking about software architecture. We have briefly gone over through this in the last the session already. So just to re-emphasize, I don't think there is a good architecture or bad architecture until unless it is sufficing your purpose. But down the line, when you are increasing your load share or you are just evolving your software, then there is some benchmark that you need to follow. If you're not following that benchmark, you will end up in the poor design choices category. So when we say good software architecture or the design is good, then it should actually fulfill evaluability, maintainability, availability, and security perspective of that system. and already and always the maintainability should be low. So it should not happen like um, after 2 or 3 years you are paying more than what you have already paid for the initiation of the project. So it should not be like that. And when we say poor or hasted design choices, then obviously that is a progressive architecture erosion that is deteriorating. Your system is declining in the performance efficiency, and it is not able to suffice all the client's need. So these are the two benchmarks that actually divides the good architecture and the poor architecture. And one more thing, it is impossible actually to say, in other words, it is not possible for any developer or any team or any company to eliminate all the tech debts, because ultimately erosion and degradation happens over time, because the demands, if demands is increasing, you have more and more requests coming, you have more and more clients requirement, you have to add more and more codes to your code base. So ultimately there will be more text, more dependency, more libraries, and hence there is high chances and high risk of degradation and erosion. So it is not possible to just eliminate the erosion part from your system entirely. But we will look at the preventive measure, because always the prevention is the better than cure. So our responsibility is just to prevent things, right? Because ultimately if it is prevented, then we have less chances or less risk of getting into the cause. Moving to our next topic, that is technical debt. So when we say technical debt, whenever you heard this term, this is more around your system need or your some component needs the refactoring and improvement. So it may be due to some bugs that has been introduced intentionally or unintentionally. It is not like somebody is just putting something intentionally. It never happens. When you trust, you have trust intacted in your team. But yeah, technical debt is more around the technical. So it may be smell, it may be the complexity of your code. So it may be test coverage. You're not covering the test of your functionality. So those are tech debts. But one question that we often ask ourselves is tech debt bad? We often take tech debt as in the negative sense, right? Because we don't want tech debt in our project. But let me tell you, it is not always bad, because the priority of any project is to delivery, because client don't uh, concern much about what libraries are using and what things are inside the system. They are more about the features. So basically you have to make trade-off at some point of time to get the viable product. So let me just, yeah. So if you know today, if you are able to give out the viable product with some technical depth, then you can actually go for it, because priority is always the feature. And but if you are just keeping that tech debt for long, then it become the pain. So if you are doing the consciously, then sooner or later you have to remove that tech debt. So not all tech debt are same. When we say tech debt, we often think there is some code issue, there is some complexity issue, somebody has not written the code well, or there is some naming convention or standard is missing, those kind of stuff. But it is not always the same, because technical debt is not only related to the code. It may be related to the library. It may be some vulnerabilities that has to be fixed. It has not been catered yet. And basically when you know you have a tech debt, right? So you have to prioritize that tech debt one way or other. So when you are in agile methodology like in ThoughtWorks, we have something called sprints. The sprint, there's a sprint in ThoughtWorks when we are in the development phase. So you have to decide in what sprint, what technical debt you have to eliminate. So you have to prioritize based on the we will see what factors we have to consider when we say the analysis of tech debt, just in the next slide. So analyze the tech debt. So ultimately you know you have tech debt, and but you have to prioritize it, right? In that case, you want some factors to check at what level or at what stage this debt is. So in that case, I would like to share one quadrant. This is famous quadrant by Martin Fowler. So basically it actually shows the intentional or non-intentional way of taking any decision. So if you are taking any decision deliberately and recklessly, then it is something that inevitable, you have created an inevitable tech debt. So you are reckless and you are deliberate to take action, then it may cost you to the inevitable debt. Second is deliberate and prudent. So prudent is basically you are conscious about this, and deliberately you are taking. So this is informed decision. So you know about this, and you might take this debt in the next sprint and to eliminate this. So this is the best thing that you can do. And coming to the next, then inevitable, inadvertent and restless. This is so inadvertent is something that the unknowns. So in your project, you have some unknowns. You don't have much clarity on something, and still you are taking any decision. Then this is something that you might regret in later. So it is things that you really should have known, but you didn't. And the last one is inadvertent and prudent. So there are lots of unknowns in your project, and still you have to move forward consciously. Then you will be in the analysis paralysis mode in long term, and that is something it takes a lot of money and effort from the developers or the team basically. So let's come to the point when you want to analyze the criticality or the severity of the tech debt. How you measure that? So basically, you have this these following points you should cater. So type of impact. What type of impact this debt gives you? So it is hurtful to the system in the long term or short term. The amount of impact. So is it making any business impact, or it is just the text, the security vulnerability? In other words, will it be making any business impact? The money is involved in this tech debt or not? The duration of impact, how long this will last, or for how long this is, and will it be recurring? So is it in the periodic fashion, or it is just one time? And the age of tech debt. So is it legacy? So if it is legacy, then I think you should fix this at the priority, because ultimately you are evolving your system, and if there is any legacy tech debt, then it will actually be the part of your code. It is very important to decide. This is the parameter is very important. And is it intentional or unintentional? So basically, we have already discussed, if it is intentional, then it is informed decision, and that will be solved in the coming sprint. And the refactoring cost, how much time and effort this particular debt will take. And when I say time and effort, it involves actually money as well as the effort of the developers and the interaction with clients and all those things. And dependency with other debts. So let's say today you have some you have some debt, and this debt is dependent to some other debt. Then what would be the impact? Should I solve the next debt first or this one? So these kind of things that you should think about. Moving to the next topic, that is software erosion. So we have already discussed about the technical debt, right? So ultimately, technical debt, non-technical debt, every debt will lead to this software decay or software rot. So what this will do is it will actually decline the system performance, the adaptability or availability of your system. Your system will not able to encompass the incoming request, and it will not be able to incorporate future future requirements of the client. So it will be brittle code, or you can say that it will be brittle, and at the worst case it may need you to write your code entire from the scratch. So that is quite costly. Moving to next, oh sorry, so we have one more thing in this software erosion. So basically, if you are keeping your TED debt for the legacy, so if today you have a TED debt and you are keeping it for long, then it will become the part of system, and that will be the legacy TED debt for you. And so impact of software erosion. So what impact does the software erosion gives? So inability to meet requirements. Your client has some requirements, and since the code is brittle state, code is not able to the project is not able to encompass any more requests, then it is something that you should consider. Like you will not be able to meet your requirements, the client's requirement. It will actually degrade the performance of a system, declining performance. It will cost you. When I say cost, it is more about the effort of the developer. They will need to make some changes in the code base itself. So you may need to change the design patterns or something like that. So it is time taking and the effort taking. Degradation of quality, of obviously, because ultimately you are reworking or reinventing the wheel, which could have been reinvented long back. And the brittle code. By now, you should be familiar by this term, brittle code. So mostly we often consider the technical cause of the software erosion, but that is not the true. We'll see what are the non-technical causes for the software erosion. But when it comes to technical causes, they are mostly driven by the decision that a particular person we may call maybe developer, maybe tech lead, maybe architect, or somebody in the team or in the project has taken. That might be intentional, non-intentional, but that becomes the one major cause of the erosion. The duplicacy of code, you are just keeping the dead codes or the duplicate codes in your code base. It is just de-retooting your the entire project. Increased coupling, increased complexity, and the incorrect architecture of the project. So, basically the last session was about the delivery app, right? So if you are just using some microservice, just sync based architecture, then in future you might have to transform that microservice architecture to the event driven architecture because the requirement has changed. So it is important to know what is the requirement and what architecture will suit that requirement. Now coming to the non-tech causes. So basically it is not always the tech causes. Software erosion also happens due to the pressure, schedule pressure. That is, if deadline is there and you have to release something, then people actually do not get into the research mode. They start implementing what they know. And organization has no process. So basically, especially in ThoughtWorks, we do have a process of TDD, the agile methodology. So we know how important that is. But if the organization has no process, then ultimately developers don't know what they are doing and how a particular process works and how the quality has to be integrated in the project. Now, the interesting part is smells. What is smells? We know code smells as a developer, we all know. But what is architectural smell? We'll look into a minute. So just to quote Martin Fowler, code smell is symptoms of possible problem that can be removed from the refactoring step. Martin Fowler has good book on the refactoring. I will encourage you to go through it and read it. And, obviously, smells are those things that might affect the system in terms of evaluability, maintainability, and all. So it ultimately impact the quality of the system. And code smell is just a surface level indicator. It actually gives you indication that there is some programming flaw in the system that you should fix at the priority. But when it comes to architecture smells, so basically code smells is more about your function level code and your class level codes, and you are just not able to incorporate that in effective way. But when it comes to architecture smells, then it is more about the designing part. You are not fixing, or you're not keeping the component where it should be. Or let's say you have two components and you are not able to engage those components in effective way. So you might be leading to circular dependencies or the God component, we say. We'll see that in a couple of minutes. And so architecture assessment can have large effect on the software maintainability. So we know code smells mostly deals with the daily life. So you are writing whatever you're writing, that you should consider in the code smells. But architecture smell is more about when you are done with the functionality, you have something to provide to your client, and then when you are in maintainability mode, then it will destroy the scope of this expansion. You will not be able to extend any further because the code brittle code. Now, quickly, I will just go through the code smell. People actually know this is just a slide. So we have few types of code smells. Bloater code, the long methods, the long classes, long parameter list, object-oriented abuser. So basically, switch statement are considered to be the anti-patterns when it comes to the code smells. Alternative class with different interfaces, coupler, the inappropriate intimacy between two classes and all, and dispensable, so dead codes and duplicates that resides in your the code base. Now the crux of this session is this architecture smell. So people often ignore these part. People often deal with this, but this is very important. Cyclic dependency. What is cyclic dependency? Basically, when you are trying to make two or more components talk to each other, but such that they are interdependent and they are making a cyclic cycle. So if A component is talking to B and B is talking to again A, so it will not be able to successfully spin up, or it will not be able to successfully incorporate the requirement. We'll talk about the mitigation of this as well. We have particular tools, we have frameworks as well that actually tells what kind of cycler dependency your project is holding. Unstable dependencies. So basically, today we know about after this security vulnerability, there are some libraries or there are some tools that are not very much stable. They have more and more vulnerabilities within them. So you should avoid that, because that again will be the architecture smell. This black duck is a tool that we often find around. This helps you to actually find whether the dependency is unstable or stable, and whether that particular dependency holds any security vulnerabilities or it is a legacy dependency. Coming to the God particle, it is basically when your component is extensively large and the line of code is very huge. So actually it will not be able to suffice its purpose. And feature concentration. So basically when your single component is actually incorporating the feature of multiple feature of your project. So let's say you have feature A and feature B in your project, and you have component X, and component X is talking to both the features. It will actually become hard. It will become hard to maintain that feature X, because if you want to make any changes to the feature A, you might have to deal with the same functionality in the feature B, and they might be independent. So it is not recommended anyhow. Scattering functionality is basically when you have multiple components doing the same thing in your code base. So you have to have a principle of single responsibility, the solid principle that the colleagues had talked about. So your function should be intact. It should not be roaming around. That is scattering functionality. And dense structure is basically when you are relying too much onto the dependency, and that dependency has some transitive dependency within. And surprisingly, Black Duck actually caters for the dense structure as well. So we'll look more tools to clear all those. Okay. So now the question is, we have saw two types of smells, the code smells and the architecture smells. Are they related? The first question is that, and which should be handled first? So basically, code smells are the basic level, unit level smells, So when you are dealing with the day-to-day coding practices and all, you should actually incorporate that. But what about architecture smells? So architecture smells are not the daily use case smells. It should be considered in this cycle in periodic fashion. So let's say you have a sprint of 15 days. In the last sprint, you just saw what do we have any smells or not. Are they related? Yes, they are obviously related, because ultimately code is the unit of your architecture, right? And if your architecture is smells, then obviously if your this code has smells, then architecture will obviously be deteriorating by the time. And which should be handled first? Obviously, the code smell. The code smell should be handled first, because ultimately that will be the next step for the architecture smell. Cool. I think we are in the midway. After this, we will be talking about the mitigation of these smells and all. So by now, do we have any question with us? Kirti, do we have any question, or should I continue?
Yeah, Sunil, we don't have any. You can continue.
Cool then. So yeah, let's find a way to mitigate this at two levels. So basically, as we saw, two levels. One is the code level, and the other is architecture level. So code level mitigation. Code level mitigation, when we say, then I believe there are few ways that we can actually mitigate these things. The design pattern, and the continuous refactoring culture, it actually applies. It actually varies from team to team whether they are following this refactoring culture or not. TDD obviously, and code smell detection tools integrated to your CI/CD. We'll talk about it. So migration mitigation at the code level. Obviously, as I told you, prevention is better than cure. Always try to prevent something than to just rescue it. So software erosion and tech debts are not available, are unavoidable. So it is important to comply with the extent. So it does not make any damage to the lifespan. So coming to the design pattern, we all know what design pattern is, but it is very important to select the best design pattern based on your requirement. There is some trade-off with the design pattern as well. Like it is not always the best to go with one design pattern, because what happens if your problem itself needs hybrid solution. So it is upon the discussion, the tech hurdle that you might have in your team. It is upon those things that you come up with some design pattern that actually fulfills your requirement, and it will not be deteriorating your architecture as a whole. If you want to know more about this design pattern, I would suggest the cool website that I've actually gone through. This is the one that I would suggest you to just go through it. It is very well written, and it will actually give you the glimpse when to use and when not to use, and what are the trade-offs of design pattern. Coming to the next, the periodic refactoring code and retrospective. So basically, this is a team activity that you can do in the team. So refactoring code, the tech debt is there, and you have something in your backlog. So just get it out and see the scope of it. If you can prioritize it, it is well and good. Prioritize it and do the refactoring. For the refactoring, the same link actually has the part of refactoring in it. So the same link, the refactoring.guru. You can actually see what are the code, smell, dirty code, clean code, and all. You'll find it here. Next is TDD. Obviously, ThoughtWorks is not about TDD. And TDD actually suffices the purpose. I think there is a lag. Hello.
Yeah, Sunil, I think there is some issue with the network from your end.
Is it okay now?
Yeah, better.
Cool.
Yeah, I will tell you if there is.
Sure. So basically, TDD test-driven development that we often find ourselves in ThoughtWorks. So basically, you're writing some code, and you want your code to be justifiable. So you don't want anybody tomorrow coming to your code base and writing something that does not even comply with the definition of the function. So TDD actually justify that. So it actually restrict your function or class or the code base or the component itself to do what it is intended to do. And then we can come to the and by the way, if you want to know more about TDD, how it works and all, just Google it, the ThoughtWorks with the TDD culture in ThoughtWorks. We will have some great blogs written in the ThoughtWorks itself. And the smell detection tool that we will be looking in next slide. So we have quite a famous, some are open source, some are not, tools that we can actually use. One of the famous one is the SonarQube. SonarQube actually tells you about what are the bugs in your code base itself, what are the vulnerabilities, and actually, interestingly, it actually tells you what kind of debt your code has and how many days or how many hours it will take to resolve those debts. So this is the tool that you can actually just research it on, and you will find it easily. It is it is also provided in the Dockerized way. So if you know Docker, it is very much easy for you to use this on RQ. PMD is another tool that you can actually look forward to. It is kind of the same. It actually gives you the code smells in your code base. One other way to mitigate the code smell is the IntelliJ or Eclipse, especially for the Java. To use these plugins, we have multiple plugins in the IntelliJ itself, and we have few more products like the Talisman, Detect KT, and ESLint. So these are a few plugins, or say small code bases that you can use to eliminate those code
Uh,
smells.
Sunil, sorry to stop you there. I
Jankati?
think there is a small lag from your end. Maybe can you turn off your camera for
In
some
that
time?
case,
Yeah.
yeah, I think that will work.
Yeah, sure. Continue.
So yeah, I think this would be good. So architecture level mitigation, this is again why we are here, architecture level mitigation. So We will talk about evolutionary architecture, that is the famous or the running terms in the ThoughtWorks. Periodic upgrade and vulnerability check. I will talk about my own experience in that. And the architecture code smells and detection tool. We will again take some tools with us. So evolutionary architecture. Basically, this is a concept where you should comply with some idea and methodology, so that you are evolving over time. You are evolving your system over time as per the business priority changes, customer demand shifts, or there is some new technology in the market, and you know that will actually improve your performance, improve the performance of your system. So if you want to know more about evolutionary architecture, then again search for ThoughtWorks evolutionary architecture. You will get a good, awesome blog. Obviously, there is a trade-off. I encourage you to look over that itself. Periodic upgrade and vulnerability check. So basically, this is how you don't have to keep your eye on the latest tech stacks and all. So you should make these things automated, right? You should know when update is available and all. In that case, I would encourage you to look forward to integrate something called the tools in your CI/CD. If you're using Jenkins or you are using GoCD or Git Actions, you can actually easily integrate those things in your pipeline. So one thing that we often do is in our CI/CD, we actually integrated Black Duck. You know, Black Duck is the tool that we have already discussed about checking over the security vulnerabilities and all in the project. So whenever you commit something on the Git, it actually checks whether the project or the repository has some issues in it or not. If there is, it will actually fail the build. So you will fix the build, you will fix the vulnerabilities, and then it will actually go to till the prod. So this is the one way that you should, or you can mitigate. Coming to the architectural detection tool, I find two famous tools. One is GeekNight, and GeekNight is not a tool, but still you can download it for the trial purposes, and it will actually give you cool dependency structure matrix, the trend analysis smell distribution map. So that smells we have talked about, the circular dependency and the God component, those all can be cached through this GeekNight. And second is Q-Score. So Q-Score is an open source platform. It will actually give you a good visualization about the scores or about the smells that your project might have. I can quickly show you the interface, how Q-Scored looks. So if you see, there is one project. It is actually in their website itself. And in this project, they are showing there are six God components in the project, and the one cyclic dependency in that. And interestingly, it also tells about the design smells and the implementation smells. So long statements, or you can say the magic number. So you can go through it. If you like, you can actually use this as well, because this is obviously an open source for you. And with that, I think this was it from my end. I think I'm again open for a Q&A. If there is any, let's talk about that.
Hi everyone. Please feel free to post your Q&A session, or if you have any questions, please feel free to raise your hands.
I know people are more interested about getting into the architecture thing. People want to know about architecture, monolithic microservices, and event driven. But we often find ourselves missing about this critical for the availability or the maintainability of your code in the long term.
Okay, then I think we can wind up. So thanks, Sunil. It was a nice session, and thanks both Kevin and Janki also. Thank you everyone for joining us today and being with us for part of this Geek Night event. So thank you everyone. Just a reminder that, as I said already, we will be sending a survey. So please feel free to post your feedback about the session, as well as if you have any feedback about our speakers also, please feel free to drop it so that we can improve. Yeah, that much about it. Thank you everyone. Thank you for joining once again. Bye.